personality from this moment on. Know that, but we're going to work with it first. And here are the facts. The arrows. First level of learning this. Know the arrow system, and there is a diagram in the book. And I sometimes hesitate to show this because there are so many exceptions. This is on page 184 in your book. Right down here are ionization energies, and there are a load of exceptions. You are not responsible for the exceptions, but the overall trend for first ionization energy is, as you go across a period, they tend to increase. As you go down, they tend to decrease. So, if I look at the second period up there, lithium through neon. Okay, here is neon. Here is lithium. And so as we go across from lithium to neon, overall trend is increasing. Now, yeah, we take a couple of little dips in here. You're not responsible for that. Just know the overall trend, and if you answer the questions based on those arrows, you will be fine. Now, that's going across a period. We are increasing. Those are the facts. Okay, what about going down a family? Okay, if I choose nitrogen, I'm in the 5A family. Nitrogen to phosphorus. Okay, see how we've decreased a little bit? And let's stop it right there because it gets even harder to interpret. But the thing to remember is don't get hung up on pictures like this, graphs like this. Here's your trend. Okay, now, second level. How do we explain this? Let's go down a family first. Why is it decreasing? Why does it cost you less energy to rip one off as you go down a family? Okay, if this has been an OWL, and I'm sure it's been in a physics or physical science class you've had, you got a positive and you got a negative. They are attracted to each other, and that attraction falls off really, really fast with distance. In your book and in physics classes, you see this equation, just how fast that falls off. Okay, so, if I've got a hydrogen, here's its nucleus, this electron in its outermost level, because if you're stealing from the outermost level. The action is always with the outermost occupied level, because that's what's in touch, in contact with the rest of the world. So if we're going to lose an electron, we're losing it from the outermost. Okay, here's a hydrogen, its nucleus. Here's its electron. It's in the first major energy level. That is pretty close. Okay, so it's going to be attracted pretty well. With lithium, I want to steal an electron. Okay, the electron I would steal is now on the second. And so it's a greater distance. And so the effect of the nucleus is less on this electron. So as you go down, same old story as before, it's a distance thing. Attraction falls off with distance. Okay? So, if there's less attraction, easier to lose. Okay. You got a significant other that you want to get rid of. Okay, not murder, I don't mean that. You just want to say, you know, get lost, don't be in my life anymore. Okay, if that guy is right here in Houston, physically pretty close, okay, he can drive by your house every day, he can follow you to work, follow you to school, call you every day, and really be problematic. It's going to cost lots of energy, you know, maybe a court order, to get him out of there. Okay, on the other hand, what if he's out in California? Okay, you write him a letter, Dear John, get lost. Okay, the attraction, fondness, or distance does not make fondness or the heart grow stronger, or whatever that little phrase was. If the guy or gal sexual equality here. If that other person is way out in California and you say, go get lost, well, hey, they can't hassle you nearly as much. They're not here in town to drive by your house or follow you to work. In the old days, before cell phones, it had to be a long-distance call, and that cost money, and so there were fewer even phone calls to harass you. But now, thanks to the internet and cell phones, yeah, they can be on your Facebook, and they can do all this kind of stuff and cause you trouble. But distance, easier to lose. And so, as you go down a family, you won't remember the O's at all, but you'll remember about losing your boyfriend and your girlfriend. Okay, so as you go down a family, it's a distance effect. Easier to lose, costs you less energy if it's a distance.
I mean, so before you go down to the left, it'd be like
less energy. But still, you're 1A family, and we're just talking about making +1 for anybody, because it's the first ionization energy only we're discussing. Okay, if I want to steal from rubidium, you spot rubidium up there? RB.
Is that RB?
Yeah, RB. If I want to steal 1 electron from rubidium, it's going to be a lot easier than from lithium, because it's a greater distance. Okay? You got something really valuable. You keep it close to you, don't you? You got something really valuable, you're going to keep it in your room. Say you got a nice expensive laptop, you keep it in your room. Leave it in the rest of the house, well hey, maybe a brother or sister or somebody can steal it from you. Okay? Maybe a repairman can steal it from you. What if you left it out in the yard overnight? In my neighborhood, you would not see that again probably. And so you keep stuff close to you. So if it's a greater distance, easier to steal. All right, now as you go across, it's not a distance effect, because if you take that second period again, we're still just in the second major level. We're trying to steal from the second major level, so it's not distance now. Okay. How much are you being attracted by? Okay, well, you got lithium. Remember the story you heard before? Okay, lithium's got +3. And these electrons are acting fairly independently of each other. It's attracted by +3. Okay? If I go across, say, to nitrogen, now the attraction is +7. It's going to take more energy to overcome that attraction. Okay? So,
They both work like hand in hand. Like
yeah, for every trend we look at, this is a distance, and I'm not going to bother to rewrite what I had before. It's the same story. And as you go across, effective nuclear charge is increasing, is what explains whatever trend we look at. And so if we start making a list here, this is ionization energy, increase, decrease. Notice how these are opposites of each other, but this little setup is just the opposite of that one. Okay, now let's work a problem.